Okay, we're looking at problem 13 in a chapter 7. This is a interesting one. It's got two angles that are 5 by 3 by 1/2. So there's two of those. So we have a 5. Let's undo that a minute. Go this way. 5 by 3 by 1/2. There's two of those. These are what are called angles. So we're going to need the A value from the appendix, and we're going to need the IX and the IY. Now, these are unequal leg angles, so this is the 3-inch value here, and this is the 5-inch value here. So we will need the centroidal axis. This is going to be your Y bar distance and your X bar distance, and they're not going to be the same. And make sure that you know that this one should be greater than this one based on the way they're oriented. So we will go back and look at that information. We have a plate here that is an 8 by 3/4 plate. So this is 8 by 3/4 and for the plate. So we're going to go in and do the centroid on this first, using that as the origin. And what I'm going to do is I'm going to set the chart up. So we'll get the X bar and the Y bar distance. So we're going to have shape, and we're going to have area, and we're going to have X, AX, Y, and AY. So I'm going to let you guys look up your information, but or you can verify it. But for the area of this, if you go back to Appendix A, for the 5 by 3 by 1/2, you should be coming up with 3.75 square inches. AX is 9.43, and IY rather, IX and IY, so this is 2.55, and those are both inches to the 4th. Now notice that this is longer, so this should be stiffer in this direction than it is in this direction, and that's what that's reflecting, okay? So if you get those reversed, you're gonna have a problem, obviously, in terms of moment of inertia and when you calculate the centroid when you get to that point. We also need the centroidal distances. So this distance here, if you go back to the chart and look that up, that's 1.74. And this distance is 0.746. And that should also make this sense to you that since this is the 3-inch, this is going to be smaller than this one, which is the 5-inch. Okay. So we'll call this guy down here shape 1. We'll call that shape 2, and this one shape 3. So I'm going to go with shape 1 first, shape 1, and then we've got 8 times 3/4 gives me an area of 6. Okay, so the X bar distance is just going to be half of the distance. So that's 8 divided by 2 is 4. 4 times 6 is going to give me 24. Then we're going to have the Y distance off of the origin is going to be half of 3/4. So that's going to give me 0.375 times the area is 2.25. Okay, shape 2. Shape 2 is our angle here. The area of that is 3.75. The X distance is the distance from the origin over to his centroid location, so that happens to be from the chart, 0.746. So A times X gives me 2.798. So the Y distance would be the distance from the origin up to that point on this, and that's going to be 3/4 plus 174. Okay, so that should give us 2.49. 2.49. We're going to multiply that times the area, and that gets us 9.338. Okay, shape 2. Shape, or 3, right, excuse me. Same area, same type of shape. The X value on this one will be 8 minus coming back this way, which is the same as that. So you're going to go 8 minus 0.746. And that should get you 7.254. So AX is going to be X times A, and that gives you 27.201. Y is going to be exactly the same distance as it was over here, so we're going to just copy this down. 249. Multiply the Y times the A, gives us the same number, 9.338. Summing that column, summing that column, and summing that column, we get 13.5. We get 53.999. You can probably round that to 54 and 20.926. So X bar is 53.999 divided by 13.5. And what that gives us is approximately, it's should be 4, and yeah, that's what it's when you round it out. You're going to get 4 inches. Okay. Y is the 20.926 divided by 13.5. That is equal to 2.5. Nope, 30. 1.5. 5, a little bit over 1.55. Excuse me. So that's in terms of inches. Okay, so that's our Y bar distance. So that's operating this way up, and the other one's right dead middle. So what we're going to do is we're going to replace or add this information in here, and then we'll go through the moment of inertia. Okay, so let me go ahead and put that up there. Okay, so now that we have created or calculated the centroid location, we know that this is your Y and this is your X, and this turned out to be 1.55 inches, and this turned out to be 4. Okay, so we're ready to now go in and do the moment of inertia. We'll look at the X direction first, IX, and then we have A and D, AD squared, and then IX. So again, we're looking X location to X location. So for shape 1, the I value for shape 1, this is going to be the base. So it's going to be 8 times 3/4 cubed divided by 12. Not going to give us much of a value. We get 0.281, so very, very small value. The area of shape 1 was determined to be 6. So the distance for this would be centroid of this shape to that location there. So the X of the composite to the X of the shape itself. So you have 3/4 divided by 2. You're going to subtract that from 155, and that should give you then 1.175. We're going to square that times 6. It's going to give me 8.284, to which we will add the small incremental value there. Gives me a total for that shape of 8.565. Most of the resistance is coming from the fact that it's displaced from the centroidal axis of the composite. Okay, let's look at shape 2. Shape 2, the IX rather is 9.43. His area is 3.75. So from this axis to that axis, that difference right there would be 3/4 plus 174 minus 155. So 3/4 of an inch plus 174 minus 155. That'll get us the D value. And that turns out to be 0.94. So that distance then squared times the area is going to give us 3.3144. So we're going to add that to that. Gets us a total then of 12.744. Shape 3 is really kind of an identical situation. So we've got same moment of inertia, same area. The distances will be the same. AD squared should be the same. And the sum of those will be the same. So we sum that up. This will be the IXX inches to the fourth. So it's not giving us a lot of resistance to bending. So let's look at the shape, or the Y rather. We have Y area D, AD squared by Y. Shape 1. So now we're looking at this shape, base times the height cubed divided by 12. So 8 cubed times 3/4 divided by 12 gives us 32. So notice how much stiffer it is. Way difference here. Area is 6. So the distance here is the distance from here to here, and they're coinciding. So what you're getting is a 0 because we're looking, remember, in this direction now. From y-axis to y-axis. So that gives us 0. 0 squared times that is 0. So ultimately, you're getting just 32 here. Okay, 2. Now we have 2.55, and that's coming by the chart. Area is also a chart. Look up 3.75. Okay. So the D distance will be the distance from this point to this point. So if you take 4 and you subtract from it the 0.746, that'll give us that distance that we're after there. So that gets to be 3.254. Square that times the 375 gives us 39,707. We add these two together, you're going to get 42.257. Same moment of inertia, same shape, same area. So when we look at this one, what we're doing is comparing or getting the distance from this YY centroidal axis to this YY centroidal axis. So because of symmetry, this distance and this distance is the same, but you could also look at it this way. You could take 8 minus the 0.746, and you should come up with the same number, okay? So either by symmetry, you could recognize that, or you could solve it, but either way, you should come up with the same number. Square that times the area, we get 39,707. Sum that with that, you get 42.257. Sum these guys, you get 116.51 inches to the fourth. And this would be what we call our IYY. So it's definitely stronger if we would load, or not stronger, but more stiff. It's stiffer if we load it this way or this way, as opposed to this way or this way. And the other thing to recognize, this is what we call an unequal leg, because they don't have the same numbers here. So these numbers are going to change. So that makes this a little bit more confusing. And you really have to think about that when you get into doing the centroid, and also when you get into doing it down here. Okay, so channels Channels are pretty straightforward. W shapes are pretty straightforward. Angles can be, but they just take a little bit more of a thought process sometimes. So that should take care of that. And again, that was problem 13.